Hello and welcome to Math IPREP Part 1. In this section, we'll be going over fractions, decimals, percents, and factoring. So first, let's talk about fractions. So numbers are not finite. That means between every number, there are more parts. So some examples of this are rulers. As you can see to the right, you have a 5 and a 6, and you have all these little tick marks in between, which represent values, right? Another example of fractions are measuring cups. So you have a whole cup, half cup, quarter of a cup, and these are all ways of taking parts of that whole. Could you think of any other real life examples of fractions? Well, one I like to think about is pizza, right? So you have your slice of pizza. Not a great pizza here, but you cut it in half, right? You get your pizza cutter, you cut it in half, maybe fourth, maybe you cut it a couple more times, and now you have 8 pieces of pizza. So altogether, these 8 pieces make one whole pizza. But since we've cut it into 8 parts, each individual piece is going to be 1/8 of the pizza. And then if you add all 8 together, you'll have 8/8. So just kind of another way to show you how a pizza is another fraction we use, and that fractions are part of a whole. So let's go through a problem together. You have a recipe to make food for 8 people. This recipe calls for 8 eggs, 4 cups of flour, 2 cups of sugar, and 1 cup of water. You decide that you only want to feed 4 people. How many of the following do you need? So first, let's kind of go through what our question is asking. So we have a recipe for 8 people, and that recipe calls for 8 eggs, 4 cups of flour, 2 cups of sugar, 2 cups of sugar, and 1 cup of water. And the question we're asking is, if we only want to feed 4 people, then how many do we use? So one way you can think about this is fractions. So if we have a recipe that makes 8 people, and we need a recipe to make 4 people, 4 is going to be 1/2 of 8, right? Because 4 times 2 is 8, so 4 is going to be 1/2 of 8. So then what we can do, we can take that 1/2 and we can apply it to all of our ingredients. So if we have 8 eggs in our original recipe, then we take 1/2, and as we kind of talked about already, 8 times 1/2 is 4. So we'll have 4 eggs, or half the amount of eggs. Flour, we're going to take 4. Half of 4 is 2. So 2 cups. We have 2 cups of sugar. So half of 2 is going to be 1. And then we have water. So what is 1/2 of 1? So kind of think about if we have that pizza, we have 1, we cut it in half. This is 1/2, right? So we're going to have a 1/2 cup of water. Go ahead and move on to the next slide. So let's talk about the anatomy of a fraction. So let's say you buy a pizza to share with your family. If there are 2 people in your house, then you each get half of a pizza. So kind of talked about earlier, you have this pizza, and if we cut it in half, right, you have 2 people. This is person 1, person 2. You each get half of the pizza. So we look at that fraction like this, right? You have 1/2. So that 1 is how many portions you get. So person 1 gets 1 portion, person 2 also gets that 1 portion. 2, which is this bottom number, it's going to be how many total portions there were. So something we call these is the top number is the numerator, and the bottom number is the denominator. So the top number is how many portions you have, the bottom is how many total portions there are. So just a question to kind of solidify what we're talking about. If you have a 3-person home, you each get a third of the pizza, right? So if you have that same pizza, cut it into thirds, you each get 1/3. And again, we can think about that as each person gets one piece out of a total 3. So as I kind of talked about a second ago, this is called the numerator and the denominator. So the numerator is on top, the denominator is on bottom. So let's try a problem here with our numerator and denominator. If you split a pizza equally with 8 people, what fraction of the pizza do you get? So remember, the numerator is how many each person gets. So we know already the numerator is going to be 1. And the denominator is the total number of pieces, right? So if we have 8 people, we're going to have 8 pieces. So therefore, each person would get 1/8 of the pizza. So then we can try that again with 16 people. So go ahead, pause the video, try it on your own, and see what fraction you get. Okay, so we have 16 people. You know, each person gets 1. So we'll start with that 1 as our numerator, right? Because that's each person. And then on bottom, we have 16 people, so 16 pieces. So everyone will get 1/16 of the pizza. So let's move on to something else, decimals. So we talked about fractions and how fractions can represent those values in between numbers. But now we can also talk about decimals and how decimals do the same thing. So decimals are also a way to show that you have a part of a number. And the way we usually think about decimals is in terms of money. So for our example, we have 100 pennies in each dollar. So if we have 75 pennies, that's 75 cents, and we represent that as 0.75. If you use your calculator, you can see where we get this decimal from. If you plug in 75 divided by 100, your calculator will get a result of 0.75. So what this tells us is that all fractions can be turned into decimals by dividing the numerator by the denominator. So as our example below shows us, we have 75 cents. We know 75 cents is out of a whole. We need 100 cents for $1. So in decimal form, we can put that as 0.75 because we don't quite have a whole dollar. Or we can put it in fraction form as 75 cents over a total 100. So let's go ahead and try to convert some of these between each other. So if we have this fraction of 45 over 100, and we want to look at that in decimal form, how would we go about doing that? Yeah, so one way is we could plug it into our calculator, right? And so when we plug 45 divided by 100, the answer we get is going to be 0.45. So we go from 45 over 100 in our fraction form to 0.45 in decimal form. So now something that's a little special about decimals that we don't have in fractions is our places. So when we talk about places, each place will have its own name, and every number is made up of these places. So starting with here, you have the tens, the ones, and then of course, after the decimal, you're gonna start with your tenths, your hundredths, your thousandths, your 10,000ths, your 100,000ths, and your millionths. And so something that's kind of weird about decimals is that we skip the ones. So assuming we go into non-decimals, you have ones, tens, and then past that hundreds, thousands. But when we go into decimals, we don't have a ones. It starts at tenths. So that first number is always tenths. So tenths, hundredths, and so on. So I would go ahead and write this down in your notebook or wherever will help you remember, because it is important that you know the names, and so we can know when people are talking about the tenths that it's that first spot, about the thousands it's that third spot, and so on. So another way, in addition to fractions and decimals, that we can talk about parts of a whole is percentages. So let's talk about percentages. So if we have 10%, that means you get 10 for every 100. And so when you break down the word percent, it's percent. So cent is equal to 100, and per is out of. So when you think percent, it's out of 100. Out of 100. So again, 10%, 10 for every 100. So let's look at an example. If you have 10 M&Ms for every 100 in a bag that you're sharing, you get a fraction of 10 out of 100, right? So what's the decimal version of 10 out of 100? We plug into our calendar, we see 0, or not our calendar, a calculator, sorry. We see it's 0.10. And then we can go further into percentages, and we see that this is 10%. Because remember, it's 10 out of 100, percent is out of 100, so we have 10, 100, so 10 out of 100, 0.10, and 10%, and these are all the same value. So again, these are all the same value. So here's kind of what we're talking about, how we kind of move between fractions, percentages, and decimals. So every time we use a decimal to make a percent, all we're going to do is move the decimal 2 places. So we look at that here, we have 50%, there's a decimal here. And if we want to make this into a decimal, we just move it here and then here. And now we have 0.5, and that's our decimal. And vice versa, if we want to do it the other way, we have 0.5, we just move this decimal over 2 places, and that will give us 50%. Now we've already talked about fractions and percentages. It's really just dividing by 100 or multiplying by 100. So yeah, let's go ahead and move on to the next slide. So here is an example that we can look at. So we start out with our fraction in the middle of 3/5, or 3/5. So using our various methods, we can go between decimals and percentages. So you can kind of see a lot of ways here. So we can go to decimals by dividing this on a calculator. 3 divided by 5 is equal to 0.6. And then of course we could put it to decimal to percent by moving that decimal point over 2 places. So 1, 2, we'll have 60%. And then this is nice because you also get to see it visually in a few different ways. So you see this circle up here, that's kind of like a pie chart. You have 3/5. You have 3 of these 5 categories shaded. Same with this kind of bar chart over here. You have 3 of the 5 bars filled in. It's a nice little visual. Same with the fish. And then this bottom right is going to be back to that ruler example. So we have 0 and a 1, and then in between we have 3/5. And this kind of all is just showing that we have so many different ways to express parts of a whole, but they are all expressing the same value. So here are some rules for success when you're using fractions, decimals, and percents. So when you're adding and subtracting fractions, you want to find a common denominator and then add the numerators. And we'll go over that more a little bit later and in our practice problem video. But yes, you will find a common denominator and then add the numerator. When you're adding and subtracting decimals, all you need to do is just line up the decimal place. And so kind of an example of that would be if you have 30.6 and 9.37. You see, we don't line up how many numbers there are. We line up that decimal point, and then we just kind of add or subtract from there. So multiplication, how we do it with fractions, is you just multiply the numerators by each other, and then you multiply denominators by each other. So for example, if you have 1/2 times 4/3, what you'll get is 4/6, which can be simplified to 2/3. So you can kind of see 1/2 of 4/3 is 2/3. So when it comes to decimals, you just multiply as if there is no decimal. So you multiply exactly how you would with whole numbers. And all you do is you're going to count the total numbers of decimals in the problem and then put the same number of places in your answer. So if you have 33.3 and 2.96, you see you have 1, 2, 3 numbers behind the decimal point. So your answer, whatever it is going to have 3 digits behind that decimal place. So 1, 2, 3. So when it comes to division, we do something a little bit different. So with fractions, we're going to do something called copy, dot, flip, flop. I've also heard it being called same, switch, flip. So what you're going to do, so let's say you have this fraction. You have 1 over 2 divided by 1 over 4. Let's say that's the problem you're working with. So that first step is copy. So you're going to write the first fraction. So get it down here, 1 over 2. Second one is dot. So you're going to put a multiplication sign, or a dot is kind of what we use a lot of the time. And then flip-flop. You're going to write the inverse of your second fraction. And all inverse means for a fraction is just flipping the top and the bottom. So here we'll go 4 over 1. So you have 1 over 4. Here you have 4 over 1. And then you just solve it as you would a multiplication problem. So you multiply your numerators. 1 times 4 is 4. 2 times 1 in your denominators is going to be 2. You simplify, you come out with 2 over 1, or just 2. When it comes to dividing decimals, you're going to complete long division as if dividing whole numbers, but place the decimal in the answer in the same place it is in the dividend. So in other words, if you are dividing, you're just going to have a long problem like this. 3.2 divided by, I don't know, 22.6, let's say, is the problem we're working with. So you're just going to complete this as you would a normal, so as if it was 32 divided by 226. But in the end, you're going to place the decimal and the answer in the same place as is in the dividend. So it's going to be right here. So keep it in the same spot. All right, let's go ahead and move on. So kind of how we talked about in the last one, I said we'd go back to this, finding a common denominator. This is us going back. So let's go ahead and talk about this real quick. So a common denominator is a multiple of both initial denominators. The initial denominator can be multiplied by some number to get a new denominator. You must multiply both the numerator and denominator by that number. So if that made sense to you, awesome. If it did not, let's go ahead and walk through it and show you what that means. So in this, we have 2 fractions. We have 1/3, we have 1/5. So we need to find a common denominator. So that's on the bottom. And so the way we do that is we find a multiple of both denominators. So we can start by listing them out. So we have 3. And if we go kind of by threes, this is how we're going to get our multiples. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. We do the same thing with 5. We have 5, 10, 15. So as we can see, we have one number in common, right? That 15. So now our challenge is to turn 1/3 into what? Something over 15. I put an N, that just means number. We can also just put a question mark. That might be a little bit easier. Right, and the same with 1/5. We need to turn it into something over 15. So now the way we do that is we kind of solve the in-between process, right? So if we have 1/5 and our end answer is something over 15, we think about how do we get from 5 to 15? So 5 to 15 is going to be times 3, right? So 5 times 3 is 15. So therefore, we do the same thing up here. times 3. So we get is 3 over 15. So 1/5 is equal to 3/15. And then we can kind of go over here and do that same thing, right? So 3 to 15, what do we have to do? What's 15 divided by 3? 5. So the same thing here, times 5. So what we get is 5 over 15. So now we have two numbers that have a common denominator, right? They both have a denominator of 15. So now we can just go ahead and add those together. So we have 5 over 15 plus 3 over 15 equals 8 over 15. That is your final answer. So hopefully that kind of helps figure out how to find a common denominator and also kind of walk you through how to add those together. Awesome. So now we'll go to factoring, and this is how to reduce a fraction. And I've already kind of been doing this a little bit as we've been going, but we're going to do an example here. So you can reduce a fraction by factoring the numerator and denominator. So in other words, common factors cancel out. So if you have 4 over 2, for example, you can kind of factor these, right? So what is 4 times 2? Or 4 equals 2 times 2, right? 2 is equal to 2. And now you kind of just cancel this out, right? They both have a 2. So your answer is just 2 over 1 or 2. So this is kind of a little example. We're definitely going to do some more on the next page. So let's go ahead and see what else we can look at. So factoring a number. So factoring is the process. That's kind of what we just did on that last one. So 4 equals 2 times 2. That is factoring. So factoring is the process of splitting apart a number or an expression into smaller parts. These parts, called factors, can be multiplied back together to equal the original number or expression. So in this example, we are finding the factors of 130. So we kind of do this with multiplication. So 130 is equal to 2 times 65, right? And 65 is equal to 5 times 13. So then we can kind of go through here and we see these are our factors, right? So 2, 5, 13. So you see them in here. And if we also do this a different way, we might get different answers, right? So for example, 2 times 5 is 10, right? So 10 times 13 is going to be one of these. 2 times 13 is 26, so 26 times 5. And of course, we see 65, 130. 130 times 1 is equal to 130, so we'll get 1 as well. So that is how you factor. You kind of just find all the different numbers that can possibly multiply to equal your main number. So let's go ahead and try it here. So let's reduce the fraction 15 over 168. So we'll go ahead and we factor the numerator and denominator. So 15 is equal to 5 times 3 or 1 times 15. So our factors are going to be 1, 3, 5, and 15. Our denominator, we have 168. So we can kind of do this. So 168 divided by 2 is going to be 84. So we have 2 times 84. 84 can be divided by 2 further to 42. 42 times 4 is 168, so we'll go ahead and put a 4 in here as well. We divide it by 2 again, so now we have 21. 21 times 8 is going to be how we get that number. And then we can split these up a little bit more, right? So we have 8 already split into 4 and 2 over here. 21 can split into 7 times 3. I believe those are going to be all of our main ones. So as you can see, there's not that much overlap between these. So the main one we're going to get is 3, right? So we can cancel out the 3. And then if we multiply these back together, we'll get our main answers. Or another thing we can do is just divide these by 3 on our calculator. And we do that. What's 15 divided by 3? 5. And what's 168 divided by 3? 56. So then we can think, do these have any more factors that we can do? So 5, its only factors are 1 and 5. It is a prime number. So unless 56 is divisible by 5, which it is not, then we cannot do anything else. So this is going to be our final answer. 15 over 168 turns into 5 over 56. All right, so that is the end of part 1 of part 1. But we can go ahead and move into part 2 of part 1. And this is only going to be a few slides, and we're just going to talk really quickly about exponents and radicals. So, exponents and radicals. Exponents are a way to write a repeated multiplication of the same number. So for example, 5 squared, or 5 to the 2, means 5 times 5. And 5 to the 3 means 5 times 5 times 5. So as you can see, when you have that 0.2, you get 2 5s. When you have the 3, you get 3 5s. So if that number was 12, then you get 12 5s, and so on. It's just kind of an easy way to show a really, really big number. So exponents can be positive or negative. So we have 5 squared and 5 cubed here. So 5 to the 2 and 5 to the 3. But we could also have 5 to the negative 3 or 5 to the negative 2 or any other number. Cool. So here are some rules we have for our exponents. So these are kind of ways that we can treat exponents and little shortcuts we can use when we're dealing with exponents. So the first we can talk about is the product rule. So this is going to be ax times ay is equal to ax plus y. The important thing to note here is that a means that this is the same number. So here we will just keep it as a, or actually we'll use 3. Let's use 3. So we have 3 to the squared times 3 to the 4th. We would use our product rules, right? So a, so we always see they're both 3, so that matches. So we have our x and our y values. This is all we have to do is just add those up for our answer. So 2 plus 4 is equal to 6. So this is 3 to the 6th. So that is the product rule. The quotient rule is very similar, but it's going to be subtraction. So if we have 3 to the 4th divided by 3 to the cubed, 3 to the 3rd, sorry, then all we're going to do is we see a is the same, so we're going to subtract. So 4 minus 3 equals 1, so that equals 3 to the 1. So that is the quotient rule. Next up, we can talk about the power rule. And this says when we have exponents of an exponent, we're just going to multiply them together. So we have 3 squared to the power of 3. What we're going to do here is multiply those numbers. So this is 3 to the 6th. So we just multiply those numbers. And that is the power rule. So the power of a product rule is just kind of a way to simplify something that we're working with. So if we have, let's say, 3x squared, this is the same as writing 3 squared x squared, or 3 squared times x squared, right? So all that's saying is these are the same. So that can help you both ways, and it can just really depends on the problem you're working with, which will be more helpful for you. Along the same lines, we have power of a fraction. So if I have 3 over 4 squared, this is the same as writing 3 squared over 4 squared. So I know I'm going through these kind of fast. Feel free to go back and watch them again to kind of make sure that you understand what's going on. But yeah, so this one, again, this is that power of a fraction rule. So you see we have 3 over 4, or a over b, and our x here is 2. And this is just going to be the same expression. Let's go ahead and 0 exponent. So all this is saying is that any number to the 0th power is equal to 1. So 3 to the 0 equals 1. 297 to the 0th power is equal to 1. It does not matter what n or what a is, to the 0 power is equal to 1. Next, we have our negative exponent. And all this is saying is that if we have 3 to the negative 2, this is the same as writing 1 over 3 to the 2. So that is how that negative shows itself in a fraction form. Again, this one is your negative exponent. So next we have our fractional exponent. So if I have 3 to the power of a fraction, so let's call it 2 over 5. So 3 to the power of 2/5. You can rewrite this as the 5 root. So I guess I'm actually going to use 3 here because it'll be a little bit easier for what we're talking about. So if it's 2 over 3, this is the cube root of 3 squared. So that's a little more complex of a rule, and you won't see it as often, but it's definitely nice to know. So those are all of our exponent rules. So now let's talk about radicals. So radicals are the inverse of exponents. So to simplify a radical, you must first factor the radicand. So imagine a radical is like a wall. N is the number of numbers that you need to get only a single number out. Any leftover numbers that do not have an n amount stay in the radical. So let's look at an example of this. All right, so here, all right, you have some rules. So to get things out, and actually I'm going to show you one before we do this, just kind of help visualize. So let's say we have the square root of 8. So that is our radical. So that's all. When it says radical, that just means this symbol right here. So we have a radical. Something we can do is factor, right? So we can factor 8 into 4 times 2. So now something you'll see here, right, is that 4 has a square root. The square root of 4 is what? It's 2, right? So we can now take out the square root of 4 because it's 2. But we have to leave in that 2 because that doesn't have a square root, right? So it's going to equal 2 times the square root of 2. So this goes to that, goes to that. So that's just kind of a little example of what that would look like. All right, so now let's go to the rules of radicals. So these rules don't really have names as much, but they do have a lot of examples to go with them, which is nice. So the first one we see is that a, and if we have the radical m of a, this is the same as equals a 1 over m. So we kind of see that in the next example, right? So if we have the cube root of 27, this is equal to 27 to the 1/3 power, which is equal to 3. Awesome. So this next one is just saying if we have two radicals multiplied by each other, we can put them together under the radical. So the square root of 5 times the square root of 3, just multiply 5 times 3, 15, you get the square root of 15. This rule is just saying that if we square a radical, we get a whole number. So we have square root of 5 times square root of 5. That's the square root of 5 squared. And if we have a radical squared, that just equals a whole number because they cancel each other out. And the reason why is because you see up here we have this 3, right? That's the cube root. On most of these, there's a 2 that we just don't write, but it's here on every single square root. So these cancel each other out, and we're left with 5. So next we have the m root of a to the m is equal to a. And it's kind of the same thing we're talking about. They cancel each other out. So we have a 3 here, a 3 here. We end up with a whole number here. So here are just some more rules that we can rewrite. So if you have the square root of a over the square root of b, you can combine those under the same radical. So the square root of 5 the square root of 5 over the square root of 3 is the same as the square root of 5 over 3. So you kind of just extend that radical to have it together, make it a little bit easier to work with. You can also do it the other way if that's helpful for the problem. So our next rule here, we have a to the square root of c plus b to the square root of c equals a plus b square root of c. So if we have 5 square roots of 3 plus 2 square roots of 3, we can add those together. So 5 plus 2 equals 7. And that's because they're both square roots of 3. If these were different, as you can see in the next one, we cannot add those. All right, and in our last problem, we can see the square root of a plus the square root of b does not equal the square root of a plus b, right? So square root of 3 plus square root of 5 does not equal the square root of 8. All right, so that is all we have for part 1. We will go ahead and you can continue watching the videos. We have also part 2, 3, and 4. And we also have some practice problem videos to kind of help you solidify some of these concepts. Thank you for coming to Math IPREP Part 1, and hope that you watch some more videos. Thank you.